All right, so let's take a look at number 11 here. So this one we can't equate the bases easily by any means, right? So 2 raised to what is 5? I don't know what that is. That's going to be a lot tougher. So we're going to have to do some work here and bring in logarithms because we want to bring those exponents down. So you have a couple options here. You could take the log of both sides, or you could go ahead and convert it to a logarithm, right? So I'm going to convert this thing to a log. So I'm going to choose to use the base on the left-hand side, so the 2 as the base of my log. So I have log base 2 of the opposite side. So the opposite side was the 5 raised to the 1 minus 2x. So 5 raised to the 1 minus 2x, okay, equals to what was the exponent on the left-hand side, so x plus 1. Okay, so just that normal conversion there. It looks a little scary, but it's the same idea. But what we can do here is we can use the third property of logs to bring the exponent on 5 down as a coefficient in the front. Okay, so we're going to end up with 1 minus 2x times log base 2 of 5. Right? Right-hand side stays the same. Nothing changes there. Just drop the parentheses. But the idea is I want to get all the x's together. So the x on the left-hand side is stuck in some multiplication there. So to get access to it, I need to distribute the log base 2 of 5 to both terms here. So I end up with log base 2 of 5 minus 2x times log base 2 of 5, and then equals x plus 1 still. So remember, the idea is to get all the x's on one side, everything that doesn't have an x to the other side. So I'm going to move all the x terms, so in this case the x from the right-hand side over to the left, and move the log base 2 of 5 over to the right. So I have negative 2x that was already there, log base 2 of 5. I've moved the x over, so I subtracted it from both sides. And then I moved the log base 2 of 5 to the other side. So I already had that 1 there, so it's going to be log base 2 of 5 being subtracted. Now, if you take a look, both terms on the left-hand side have an x in them. So if I factor out an x from both, I'm going to be left with minus 2, get rid of the x, don't need to write that in, times log base 2 of 5. Then there's the minus 1 from the x above it. Nothing changed on the right-hand side. Sorry, the pen's not looking too nice today. But here I'm just going to go through and get x by itself. So multiplication is holding those together, so I just divide both sides by negative 2 log base 2 of 5 minus 1. So that all cancels there. And over here I do the same thing. Negative 2 minus log base 2 of 5. And there's the minus 1 on the end. So a little bit messy here, but that's the answer that we're looking for in the end. Okay, hope this helps.